Good morning, students. Today we're going to talk about 20.2 disjoint and overlapping events. Now, first I want to explain a little bit what we mean by these two concepts here on the right hand side of the board. Disjoint events have another name, mutually exclusive. This is when an event can't happen at the same time in the same trial. They won't overlap. There's no intersection. I have two examples there. When I flip a coin, I can't get a heads and a tails at the same flipping of the coin. Either the one or the other one is going to happen. When I roll a number cube, a dice, I can't have an even and an odd number with one roll. Both those events can't happen in one of the rolls. If I start rolling it more times, then it's a different case. Overlapping events, when there's an intersection part. So now, two different outcomes can be in the same trial. When I roll a number cube again, I can have a multiple of 3 and an odd number. I can roll the die, I can get a 6, it's a multiple of 3 and it is an odd number. Then rolling multiples of 3 must be in here, the 3 and the 6, and odd numbers, all the rest must be in that part. But 3 and 6 will be odd and it will be a multiple of 3. Okay, so if we want the probability that A or B is going to happen, A or B, remember OR is the little basket and I put in all the possible outcomes in that basket. Then we have a law that we can use to calculate. The probability that A or B will happen is the probability of the one event plus the probability of the other one, and then subtracting when we see that one, A and B. A and B is this part where they intersect. This part must be subtracted. Now we can clearly see that there is no A and B here. It's 0. So for disjoint, mutually exclusive events, I won't subtract anything. I can just put in -0. But if they overlap, two things can happen at the same time. Then there's a part where I have this A and B happening, and then I'm going to say the probability of A plus the probability of B minus this where they overlap that probability. Let's do one example here on the board. Rena spins a spinner once that has 8 equal sections. I've drawn the spinner, 8 equal sections. They say 2 are blue, 1 yellow, 3 red, and 2 greens. The question states, what is the probability that the result is red or blue? So I want the probability that it is red, or we interpret as the basket, or blue. Using our new law, we can say the probability that it is red plus the probability that it is blue minus the probability that it is red and blue. Look at my and for the N. But can red and blue happen at the same time when I spin the spinner and it stops at something? No, the probability that red and blue will happen will be 0. I don't need to subtract anything. So the probability that we have red or blue will only be the probability of red. Now remember what probability is always like. 3 red out of a total of 8. 3 over 8 plus blue, 2 blue out of 8. 2 over 8. and we're going to subtract 0. Let's indicate to ourselves. And if I add this, I get 5 over 8. And I can leave my answer like that. In the next video, I'm going to do another example similar to this.